I wonder how efficient my kettle is. Hello and welcome to Underdog Physics. Today we'll be looking at efficiency. Efficiency is a measure of how well something transfers energy into a useful form of energy. Take the kettle, for example. Whatever energy goes in is transferred to thermal energy, the hot water.
Efficiency is equal to useful energy transferred divided by the total energy input. If 1,000 joules of energy is put into a kettle via electricity and we end up with 1,000 joules of hot water, then our efficiency is 1,000 divided by 1,000, which is equal to 1. That's the best efficiency, and also the best kettle. On the other hand, if 1,000 joules of energy going into a kettle results in only 700 joules of hot water, that is, the water's not as hot as the last example, our efficiency is 700 over 1,000, or 0.7. We can also say this is 70%, which is kind of alright, but not that great. And lastly, if you take the lid off your kettle, you'll probably only get about 200 joules worth of hot water for every 1,000 joules of energy you put in. In this case, the water's not really heating up at all and all the heat's being lost through the top. This efficiency of 20% is not very good at all.
With that in mind, there's only one thing left to do. You will need a kettle, half a litre of water, a measuring jug or something to make sure you've got half a litre of water, something to use as a stopwatch, and the understanding you're probably going to have to drink half a litre of tea to avoid waste. With your half a litre of water in the kettle and your stopwatch to hand, all you need to do is start the kettle and the stopwatch at the same time. Then we stop the stopwatch when it stops boiling. If only I had something to drink while I waited for this. Ah, nice. If only I had a biscuit as well. Nah, not today. Yes! Oh. That'll do.
For the case of our real-life experiment, I need to know what the useful energy is. So using the specific heat capacity for pure water, I can calculate the amount of energy I need to heat up half a litre of water from 7 degrees C, which is roughly the temperature of cold water out of a tap, to 100 degrees C, where it boils. We won't go into specific heat capacity right now, but the amount of energy needed is 195,300 joules. This is our useful energy output, because it's the energy we need the kettle to transfer as thermal energy. To find out the energy that our kettle's transferred, we need to know a couple of things, starting with what power means. Power is equal to energy transferred over time. Let's rearrange this equation to get energy as time times power, or power times time. My kettle took 1 minute 53 seconds to heat up the water, so that is 113 seconds in total. And looking underneath the base of the kettle, we can see that the power output is somewhere between 1,836 and 2,000 watts. So I'll find out the average of that just to be safe. 1,918 watts. So the energy transferred by the kettle is 216,734 joules. Now all that's left to do is put our numbers in the equation. The useful energy transferred is 195,300 joules, and the total energy we've put in is 216,734. This gives us an efficiency of 0.901, or 90.1% to 3 sig fig. That's not bad. Suspiciously high, but I'll take it.
Thank you for watching. I hope this was useful. Feel free to like, share and subscribe. With your half of litre...